Welcome back, and in continuation with the last day's session on hydraulic valves. The second category of valves is what we are going to discuss today. That is directional control valves or DCVs. There are two types of directional control valves: poppet type and spool type. Poppet type and spool type control valves are there using as hydraulic valves. So directional control valves are used to start, stop or change the direction of flow of the fluid. So we can start the flow, stop the flow or change the direction of flow using this DCVs, directional control valves. So they are usually specified by number of connected lines. So how many lines of hydraulic fluids are connected to the valves, so inlet, exit and some tank, and number of control positions, and what positions the valve can be regulated or controlled. For example, starting, stopping or intermediate neutral position, like that. So for example, a 4x3 DCV, a 4x3 directional control valve has 4 ways. So 4 connections will be there, 4 lines will be connected to it and 3 positions. So 3 positions that might be the beginning, intermediate and end positions. So going to the different levels or movement of the poppet or the plunger or piston, depending on the type of the valve. Okay, I hope it is clear. So in short, directional control valve is used to start, stop or change the direction of flow. So coming to the first category of directional control valve, poppet type DCV. So in this valve, it has got 3 or 4 ways, 4 connection lines to it, and there are 2 positions only. There are only 2 positions for this valve. So it can be operated up to a pressure of 630 bar and 40 liters per minute of discharge. So coming to the processional view of the valve, we can see there is a main poppet, okay, a plunger and a pressure compensating piston and a spherical poppet. Fine. When the plunger is not engaged, before that there is a pressure line P and T is the tank and A is the exit line. Fine. This is a symbolic representation of the poppet type directional valve. You can see on the top. You may note down this also when drawing the hydraulic circuit diagram. It will be useful. So here P is the pressure line, T is the tank and A is the exit line. Now in the first position, let us assume the plunger is not engaged. Okay, plunger 3, it is not engaged, during which time the spherical poppet will be seated here so that this pressure line is not engaged. Okay, and the exit line A and the tank will be connected directly through the chamber. Exit line A and the tank are connected directly. Now when the plunger is engaged, what will happen? The spring, the main poppet as well as spherical poppet will be moving towards the right, and the connection between the exit line A and the tank will get detached. There won't be any connection. It will be stopped. There is no connection between A and T when the plunger is operated. Right? Now this pressure compensating piston will be useful in this type of poppet type valve to compensate the pressure. So let us see. So when this is moving, when the plunger is engaged, this main poppet will close the connection between tank and the exit line. At the same time, what will happen? The pressure line will get connected to the exit line through this opening. From the spherical poppet. So pressure line and the exit line will be connected directly. Okay. During that time, this will allow for pressure compensation here in this area. Okay. So this is the working of a poppet type directional control valve. So depending on how much this plunger is engaged, that much will be the flow and the pressure to the exit line from the pressure line. Now the second category of directional control valves, the spool type. Advantage of spool type directional control valve is they allow designing valves of 2, 3, 4, 5, 6 ways. 2 to 6 number of ways or more. So that much of connections are possible onto a single valve, as well as a wide variety of control positions. Not only two control positions, we can have n number of control positions. So for example, you can see this is a 2 by 2 spool type control valve. 2 by 2 spool type directional control valve. So you can see here there is a pressure line and there is the exit line. Now in this, the spool is closing. There is no connection between the pressure line and exit line in the first position. The corresponding symbolic representation is given here. Now in the second position, when some force is acting here, this plunger will be moving. Now a connection is established. And the first position, the spring force will be closing the pressure line without connecting it with the exit line. Now in the second case, when it is moving towards your right, what will happen? The pressure line and the exit line will get connected. So there are only two positions as well as two connections, pressure line and exit line. Okay, two connections, two ways and two positions. That's why it is 2 by 2 directional control valve and it is spool type. Okay. Now control of directional control valves are made by any of these 7 methods. Mechanical control by hand lever, mechanical control by cam and roller mechanism, mechanical control by rotary knob, simply a hand lever can be used, or cam and roller mechanism or rotary knob, you can rotate it. Then hydraulic control, again hydraulic system, a subsystem can be incorporated. Pneumatic control using compressed air, electric control by direct current solenoids or alternating current solenoid. So solenoids are most commonly employed in these directional control valves. So either DC or AC solenoids can be employed. Now these are the symbols for DCV controllers. So mechanical, if it is mechanical controller, it is simply like this. If it is a push button, a button is represented. If you can push it and control it. In the on position, if you want to make a push start button, it is usually represented like this. And pull out knob, if you want to pull the lever out to engage the valve, so this is represented like this. When push button or pull out knob, both are present. If you have to push the button and pull out the knob, if that is the case, it is usually represented like this. Now if it is a lever, you have to turn the lever to 90 degree or 180 degree, that is represented like this. Pedal, if you want to push it using your foot, especially when it is positioned on the lower level of the ground. Then pedal, 3 position valve, it is represented like this. Then push rod is represented in this fashion. So these are the symbols used to represent directional control valves in a hydraulic system. So in the coming session, we will discuss about the check valves, that is a second, third category of the hydraulic valves. I hope the session was clear. Keep watching. Thank you. Have a good day.